Hello, y'all. I'm going to do some problem work throughs. I actually have an exam on what, Tuesday? So I'll do some problems from the uh, book that we're basing our exam on and our classes on. I was able to see the title in the lead in linear algebra book. So I'll do some problems from 1.1 and 1.2, like the book says. So it's probably end up being a multi-part little thing as I do some problems today, Sunday, and Monday. But I plan on working through several of the problems in the book, and we'll see how many I get through. So starting with the first one, I'm in section 1.1 right now. We'll see what we have. So as a little warm up, we have some pretty easy ones, just working with some vectors. Um, so we have x equals this. Reason why this was important for physics, by the way. I am a learning assistant for an EM class, and vectors are major in that class. Um, even in the Newtonian mechanics, dealing with the vectors for different forces and things like that. So even though that wasn't a vector class, I remember having to review vectors for some of the students because it was such an important part in calculating some of the things we were doing. We were doing like Coulomb force problems and things like that with particles, and it was necessary to work with vectors to get those properly. So as a simple warm-up, we're going to be adding these vectors. So it's pretty much 2 minus 1, 3 minus 1. So that'll be 1 and 2. Easy enough. Why don't we look at F? Oh, am I the wrong button there? There we go. So we had this part right here, F. That was A. Maybe I should move this other little window down somewhere. I don't want to do it now though, but I'll move it later. Actually, let me go ahead and move it now so I don't click it by mistake again. There we go. So F, we have 2x minus y. And you see the book is not doing an arrow, but whenever it has a bold, especially the arrow is understood, which I always had an issue with. And see if I can center this on the screen a bit better. There we go. So F, 2x minus y. So we had 2. I'll just input my x here. I'll distribute the negative. Easy enough. Uh, I'll go to problem 10. So find the parametric equation of each of the following planes. So I'll use this symbol for a plane that contains the point -1, 0, 1, and the line x equals 1, 1, 1 plus t 1, 7, negative 1. So I believe I wrote that correctly. Negative 1, 0, 1, and 1, 1, 1, t 1, 7, negative 1. So you want the parametric equation of the plane containing that. So let's see here. So we know that the Cartesian is basically, let's say, y equals 2x plus b. And parametric is basically taking these vectors and let's say we have a plane, we would have c1 and v1 plus c2, v2 equals, let's say, b. That'll make a plane. So basically, there must be some point at which negative 1, 0, 1 equals 1, 1, 1 plus t 1, 7, negative 1. There must be some uh, point at which that is equal. Um, let's see how we can work this out. If I bring that to the other side, we have negative 2, negative 1, 0. Right? So if I was to make this into three equations, we have negative 2 equals t. We have negative 1 equals 7t. And we have 0 equals t negative 1. Right? So let me see what the issue could be here. Because that doesn't seem like that will equate, obviously. That's why I thought I was doing a different problem. Let's see if we can figure this out, though. So if that line is in the plane, there's some t that equals that point. See which t can do that, though. Right, let's try a different approach. And I want the parametric equation of the plane. All right, let's start this way. So of a plane, going back to what we were looking at earlier, we know it can be written in the form x naught plus v1 plus v2 equals, I think I called it b the first time. If it's not going through the at least we don't know if it's going through the origin, but b could be 0, it could not be. So we know that x naught could be 1, 1, 1. So, and we know that one of the vectors is this. So basically, when we have a line, we also draw a point. So let's say that was 1, 1, 1. We call this point A. And then from that point, it goes off in the direction scaled by t. So this direction v would be this here, and the scale of it would be, whatever t is there. So what we're saying is that the plane has to be at that point, and it has to be another line that is coming from, that's intersecting with that line. And this point, I'll call this point A, is somewhere within the intersection of those things. So technically, we can say that, at least we would have to say that if this point is included, V can be equals the point -1, 0, 1. And so we could write this and say XO, I should say 1, 1, 1 equals V1 plus T 1, 7, -1. Together, these equal -1, 0, 1. So this means more like it. And this should be plus. I meant to put a plus there. So, and technically, this is being scaled potentially by something. It could be 1. So why don't we say C1? And since the other one is T, I'll just call it S. So 1, 1, 1 plus, and 1 is this point here, S V plus T 1, 7, -1 equals 1, -1, 0, 1, right? So we could bring that to the other side and say SV plus T 1, 7, -1 equals, so I have to subtract 1 from everything. So -2, -1, 0. And what can we do here? Technically, that would be the parametric equation. They didn't necessarily say they wanted us to solve for it. So we'll see if this is sufficient. We don't know what this vector is, but we know that whatever this vector is, multiplied by S, V1, V2, V3, plus T, 1, 7, -1 equals -2, -1, 0. So we'll have to write it in like a vertical format. right? So, and T is real and S is real. I don't even know if this can be solved farther. I'll have to solve for V, S, and T. I mean, of course, there's a trivial solution. We could just, but I already tried that. If we have just T equals to that vector, it doesn't work. So I would have to have a vector uh, here to make it equal that. But that could be the equation right there. I'll stop there on that one. Now B has an answer in the back of the book, so I'll be able to check this one and see if it's correct. So we have B is the plane parallel to that vector, right? So I'm going to draw this. We have a plane P, the plane parallel to vector 1, 3, 1. So somewhere on this plane, we don't necessarily know that the vector without some kind of XO is in the plane. We could say XO plus T 131 is in the plane. And we can say that what we call A 1, 1, 1, what we call B negative 2, 1, 2. That's on the plane somewhere. We don't know where, but it's somewhere on the plane. This is easy. This is easy enough. So we can get a vector from these 2 points. So I can say AB equals B minus A. That equals negative 2, 1, 2 minus 1, 1, 1. So that equals negative 2 minus 1, 1 minus 1, 2 minus 1. So that equals negative 3, 0, 1. And we'll call this uh, vector B. And we'll say that U is 1, 3, 1. So the plane will be XO plus TU plus SV. And we know that these 2 points are included because this vector is included. So we can say, matter of fact, we could even use one of these points as XO because we know they're on the plane. So I can say 1, 1, 1, so that's on the plane, plus T and U was 1, 3, 1, plus S, negative 3, 0, 1, right? And to test it, let's see if we can get V out of this. So if I said 1, 1, 1 plus T 1, 3, 1 plus S negative 3, 0, 1 equals negative 2, 1, 2. So if this works, it should be able to give me that point. So I have T 1, 3, 1 plus S negative 3, 0, 1 equals negative 3, 0, 1. This is easy enough. If we made T equals 0, then and s equals 1, that works. So if t was 0, this would cancel out. If s was 1, then you would have -3, 0, 1 equals -3, 0, 1. Right. So let's see what the book answer says for this one. 1.110b. It is more than one answer, I'm sure. Oops, let's click. All right. So they did stop here. So we actually had the same exact answer. So they have as the answer for the equation 111 s -301 and t 131. Interestingly enough, they even use the same variable. Shows I'm starting to think like these book mathematicians to judge whether that's a good or bad thing. So that would suggest that this one was an answer as well. The book doesn't show the answer for that one, but it is in the same exact form. It's just we don't know what that vector is. It's awesome. No place to stop. I'll actually go take a shower and then go get some dinner. And I'll probably come back later and do some more of these problems. I'll end up doing a lot more problems um, before it's all over. And make sure you visit the site. If you're interested in any tutoring, make sure to sign up. And I'll see y'all next time.